right, so here we are back at 10b/11b. If it says it that in the corner, it's really 11b. I don't know why it says 10b. But we are going to write equations, write linear models given two ordered pairs or given a graph. So students will be able to write the function rules given a graph and correctly use vocabulary. So let's go ahead and look at this. This is really nothing different than what we've been doing. But we can pull points off of a graph. It shouldn't matter what 2 points I give you anymore. You should be able to figure out an equation for a line. So let's look at this example. Remember, I always recommend writing a little table of values. We just need 2 points for that table of values so that we can figure out what the equation is. Now notice on this graph I am nice and I gave you the initial value. I did give you the y-intercept. We already know the y-intercept is 0, -2, but I'm not going to write that one down yet. I'm going to remind you that you can find that anyway without needing me to tell you what it was. So let's look for 2 good points. I see a good point right here, and I see the y-intercept there. I see another good point way over here. So we should be able to find that y-intercept even if all we could see were these 2 points. That's the idea here. And so this point is, let's see, -1, -2, -3, -4, -5, +1. So this one is -5, 1. And the one way over here is, let's see, 1, 2, 3, 4, 5. +5 goes down to 1, 2, 3, 4, 5, -5. All right, so we have the points -5, 1 and 5, -5, and we've got to figure out the 0 point from there. Now we can see it, but we know it's in between these two numbers, so let's leave some space in our table and see if we can figure it out ourselves, even if we couldn't see it. So there's my -5, 1, and here's my 5, -5. Let's find the slope, because if you recall last time, if we found the slope first, then we could figure out the initial value. So from 1 down to -5, it went down 6. So that's down 6, -6. From -5 to +5, they added 10. So -6 is the change in y, 10 is the change in x. We can already see the first part of this equation. If we reduce this, then we get -3/5. Okay, so that tells me this equation starts y equals -3/5x. And we've got to figure out the initial value. Again, we can see it here, but let's pretend we can't. So if our slope reduces to -3/5, that means my change in y is really -3. My change in x is really 5. So if I go -3 from 1, I end up at -2. If I add 5 to -5, I end up here at 0, and now I can see my initial value. It was just in between those 2 points. So my initial value, we already knew it would be -2, but we can figure it out from the points that way as well. So even if we can't count back using the pattern, we can use the pattern to figure out points in the middle. So let's look at that with number 1. Number 1 over here has a negative slope again because it's going downwards. So let's write down what some of those points are. I see that my y-intercept again is going to be -2, but let's pretend we can't see that, and let's go to this one. This one is 1, -1, -2, -3, -4. So 1, -4 goes to 2, -6, 2, -6. All right, so pretend those are the only points I gave you, 1, -4, and 2, -6. We would find the slope first. So the slope looks like it's going down 2, and the change in x is 1, so my slope is -2. So I know my equation's going to start -2x, and then we need to find the initial value. Well, if this added 1 right here and took away 2 here, then I just do the opposite. I can move backwards on this one. So if it was 1, 2, then I go backwards 2 to 1, and 1 would go next to 0, so I can write it up there. And if -4 went to 6, then moving backwards I'm adding 2, and so adding 2 to -4 would bring me up to -2. And so here we see our initial value is -2. So that's how we do this if we couldn't see that initial value. If for whatever reason the graph was covered right there and we couldn't quite see it, we could still figure it out. All right, let's go ahead and do this the easy way now. Let's write down that initial value. So our initial value is 0, 1, 2, 3. Initial value is 3. My next good point looks like it's down here. right there. Right there, that is 3, -1, 3, -1. So I already know b, remember we're trying to find the m and the b. The b is 3. That's my initial value. We can see that. So now I have to figure out the slope. From 3 to -1, it went down 4. So my slope is -4 over change in x is going to be 3. And so that means my equation is y equals -4/3 x plus the initial value of 3. We can see it on this graph. All right, number 3. Let's write down the points we see. X and y. I see this one. Let's name that point. 1, 2, 3, 4, 5. So that's at -5, 0. And I see my initial value up here, 0, 1, 2, 3, 4, 5. 0, 5. All right. Well, which one of those is the initial value? Remember, the initial value is the one where x is 0. And so our initial value is going to be this one. So y equals mx plus b. We've got to figure out the m. This went up 5. This went up 5. And so if my slope is 5 over 5, that reduces to 1. So that tells me the equation for this line, y equals 1x plus the initial value, which is 5, the y-intercept point. So that's just written as y equals x plus 5. All right, let's try that again. Number 4. Here we go. All right, so this one is crossing through 0, 0. So this is a proportional one. So we know our y-intercept point is 0, 0. Really, we just need to find the slope. But we can still make a little table of values. I'm going to make it on the left because I have some space there. So x, y, it starts at 0, 0, and then it goes, let's see, this looks like the next good point. And so it goes up to the point 1, 2. So it went up 2, right 1. And so the equation for this line would just be 2 over 1, or 2x plus 0. And so I don't need to write a plus 0. There it is. Ooh, here's the undefined one. All right, so let's look at this one. I know it's a little hard to see on the screen, but you should be able to see on your paper that this line has points here and here and here. And so let's write those points in a table. So this first point that we see is the point -1, 0. X is -1, y is 0. This point would be -1, 1. This point would be -1, 2. And so you should be recognizing a pattern here that there's only one rule for this equation. What do you notice is in common here? The only thing that's in common is x is always -1. So check all these points. -1 still. X is still -1. X is still -1. So the equation for this line is just x equals -1, as weird as that is, because the y's don't matter here. The change in y doesn't even really matter. It's changing by 1s because of the point that I picked, but there's 0 change for the x. So it would be written like this, and remember we can't divide by a 0. That's undefined. Or as Slope Dude would say, undefined. He'd be falling off that cliff. It's undefined. It's moving up and it's moving down. So that's not functioning. That's an undefined line. And the only rule there was x equaled -1 because that's the only thing that was consistent through the table. All right, let's look at this one. So this one's a little bit different. Let's mark the points. So let's make our little table, x, y. This point would be 0, 1, 2, 3. This would be 0, 3. This point right here would be 1, 3. This point right here would be 2, 3. So again, you're recognizing a pattern kind of like the last one, but where the last one had x's that all stayed the same, this one just has y's that all stay the same. And it doesn't seem to matter what the x is, the y is always going to come out to 3. So the equation for this line is just y equals 3. It's not changing, in other words. So the y doesn't change over the x. And so showing that it doesn't change, I put 0 over 3, but it doesn't really matter. 0 over 1 is still going to equal 0. So this is a slope of 0. 0 change. This is a slope that's undefined because it's changing both ways. All right, let's go ahead and look to number 7. Write a rule for the function that passes through the 2 points, 1, 3, and -5, -3. Ooh, I like this one because this one didn't graph it for you. So let's use our table. 1, 3, and -5, -3. Okay, for this one, let's look at the change in y. The change in y from 3 to -3 is a subtracted 6. So here's my slope. My slope is -6 over From 1 to negative 5, it subtracted 6 again. Negative 6 over negative 6 is just 1. All right, so I see my slope is 1. 1 over 1. So I could go backwards in there, or I could use my equation. So let's look at what that would look like. Y equals mx plus b. We know the m is 1. And we do have some x's and y's. So let's pick the first point, 1, 3. That y is a 3. That x is a 1. So I'm going to multiply that by the slope because I know that's happening in the equation. 1 times 1 is going to give me 1, so I know 3 should equal 1 plus whatever the b is. So hopefully now you're figuring it out. Oh, okay, well then if I subtract the 1, I end up at 2, so b must be 2. So that's the way we could work this out even without graphing. So that tells me the equation for this line, the m was 1, so 1x plus the y-intercept should be 2. Now we can graph it and see if we're right. So if we graph these points, 1, 3 is right here, 1, 3 is right there, negative 5, negative 3, 1, 2, 3, 4, 5, negative 5 goes to negative 3 right there. And if we connect those, we should see a slope of 1, and it should cross through the point 2. Let's see if that happens. I stopped breaking the lead on this. Oops. There we go. All right, so now, oh, it did. It crossed at 2. And we could figure that out from the slope and the point that we knew. Okay, so that's another way we could do this. After you find the slope, you're welcome to work backwards through the table to get back to the initial value like we did before. But sometimes that's not going to be possible. So we can use the slope and a point and figure it out as well. Let's try number 8 that way. Negative 2, 3, and negative 1, 1. All right, so let's work it out over here to the side. Make your little table. Oh my goodness, I need to stop breaking lead. Here we go. Negative 2, 3, and negative 1, 1. All right, so we find the slope first. Find the slope. So from 3 to 1, they took away 2. From negative 2 to negative 1, they added 1. So that tells me my change in y is negative 2, my change in x is 1, so my slope is just written as negative 2. Okay, so I know the beginning of this line. But I've got to figure out the initial value. Yes, I could follow the pattern from this point, or I could use y equals mx plus b. So let's write that out. Y equals mx plus b. So I know the m is negative 2, and I can pick the x and y from the table that I know will work. So the y for the first point they gave me was 3. The x from the first point they gave me was negative 2. And I can use that information to find b. Hopefully you can see that. That says plus b right there. Sorry if it's too scrunched together. Let's see, plus b. All right, so now we work out that multiplication right here. Negative 2 times negative 2 is 4. So that tells me 4 plus something. 4 plus the b gives me 3. If I subtract 4 from both sides, I get back to negative 1. So that tells me the b is negative 1. So now I've got an m and I've got a b. I can write this equation. So y would equal negative 2x minus 1, or plus negative 1. Let's graph it now and see if that worked. Negative 2, 3, 1, 2, 3, and negative 1, 1, right there. Negative 1, 1, and negative 2, 3. So let's go ahead and line those up really well, and we should see the slope end up being, negative 2, and it should cross through negative 1 on the y. So let's graph that, and as long as we graphed it well and we lined up our ruler the right way, we do see that it's crossing through at negative 1 like we thought it would, and it has that slope of down 2 over 1. So it has that negative 2 slope as well. All right, so go ahead and try the exit ticket today. See how you do with finding b when you can't graph and finding b from a table no matter what points I give you. Remember, you are always welcome to come to the back conference table and talk to me about this if you're having a hard time. All right, good luck with this. Yay, math.